Welcome back, ladies and gentlemen. I am excited to bring you the fourth video in this unit. Our focus is going to be on measurement and density. As you know, in most science classes, being able to appropriately and correctly measure things is very important. And in chemistry, it's just the same. We're really going to be focusing on the different types of units that you are more than likely going to experience in this chemistry class. And then we'll also talk about the importance of density and how that plays a role in lots of different applications in this chemistry class. So just a few learning targets for you today. Hopefully you will be able to identify and use different units of measurement in chemistry. Hopefully you'll also be able to recognize some prefixes and the impact they have on the quantity of a substance, like volume and length and whatnot. And then also be able to calculate for a variety of variables using the formula for density. That is going to be our first chemical formula, or our first mathematical formula rather, that we are going to be using in chemistry class. So as you can see here, we have a variety of different vocabulary terms, including the mysterious abbreviation SI. Ooh, I wonder what that stands for. We also have weight, mass, derived unit, volume, and density. So let's go ahead and get started with the system of measurement that nearly all scientists in the world use, and that's known as the SI system of units. It's French for something like Système International. Basically, it's the international system. It's very similar to the metric system. There are a few small differences between the two. Now, if you think about here in America, we typically don't use metric system for measurements, whereas with length, the Système International uses meters. We typically use feet. For volume, we use ounces, whereas the SI unit is liters. So there's going to be a bit of a mind shift change between what we're used to and what's used in the scientific community. But keep in mind, all of these units are still to measure the quantity of things, just like what we use in the United States with the imperial system. So the system that we're going to be using is going to look a little bit different, but the concepts are still the same. If you look here, here is a variety of SI units that are used. So as you can see, the quantity for length is the meter, mass is in kilograms, time is in seconds. And as you go down, you recognize probably a few of those, but there may be a few that you don't know. For example, temperature. Now, normally you would think with metric that the temperature would be in Celsius, but when we talk about the SI unit, it's actually in Kelvin. And we'll talk a little bit more about that when we get to things like gas laws. The main three, I should say four, that you need to focus on are length, mass, time, and the amount of substance. Now, the amount of substance is known as a mole. Now, I want you to think about that like a counting number. For example, a dozen. If I have a dozen eggs, a dozen books, a dozen cans of pop, I have 12 of something. A mole is the same concept. It's just a really, really large number of something. And as you can see here, there's a few you probably recognize, maybe ampere if you work a lot with electronics and things like that. But those are the base units for the SI system. Now, those base units, if we have a number that's really large or really small, we typically don't just use the base unit, but we add a prefix to the beginning of it that indicates kind of a multiplier, so to speak. So for example, if you look to the table to the right, you have prefixes like giga, mega, kilo, deci, centi, milli, micro, nano, pico, and femto. And these are used in the SI system to represent either really large numbers or really small numbers. So for example, a centimeter is 1/100th of a meter. The root cent, like if you think like cents in a dollar, there's 100 cents in $1. There's 100 centimeters in 1 meter. Kind of makes sense. Also, look at kilo. Kilo means 1,000. So for example, 1 kilogram is 1,000 grams. So you can see there's a little bit of difference here. With kilogram, the number is actually larger than the base unit. And if you go down to milli, then the unit is smaller than the base unit. So the ones you really need to make sure that you're aware of that we'll use very frequently in this class are kilo, centi, and milli. As you continue on in your chemistry education, you'll probably experience deci, micro, nano. You've probably heard the word decimal before, where you can get into tenths. That's where that comes from. Milli, like if you've ever heard the term millennium before, there are 1,000 years in a millennium. So lots of these have real-world applications. But the idea here is to understand that these prefixes are used to represent very large numbers or very small numbers. So I used the term mass before, and I want to make sure and be very clear that mass and weight are really two different concepts. Mass simply refers to the amount of matter something has. So if I have, a big book and a small book, then the large book has more mass. Therefore, it has more matter, so it has more grams. Weight is a little bit different. Weight is the amount of gravitational pull on matter. So when we measure weight, we're really measuring the force of gravity that has an effect on the mass of my body. So if I go to the moon, my mass is still the same. I still take up the same space and have the same amount of matter. However, I will weigh less on the moon because the gravity on the moon is 1/6 of that on Earth. So my weight will actually be less on the moon despite having the same amount of matter. And you can see on the right hand side here in this picture, it gives the same concept that the weight on the Earth and the moon for this thing is different. However, the mass is always the same. So not all of the SI units can represent all of the different quantities that we need to be able to measure. That's when we use things like derived units, which are a combination of SI units that we already know. So for example, if we're looking for a unit of area, a unit of area is measured in meters squared. That is, we measure the meters of width versus the meters of length, and we get meters squared. If you're trying to find the volume of something, like the volume of a container, we take the length times the width times the height. Well, that gives us the unit of meters squared. The units work very similar algebraically. Like if you see for area, it's m squared, which is m times m. And many of these units are also given their own names. So for example, we look at the unit of Pascal. Pascal is a unit of pressure, and that's measured in kilograms over meters per second squared. So you're going to encounter a variety of different units this year, but keep in mind that they're all really based on the same basic units we've discussed earlier in this video. Now when we look at density, density is a very important concept in chemistry, and it is the ratio of mass to volume. If something is more dense, it has a higher amount of mass per unit of volume, and if it's less dense, then it will have less mass per unit of volume. The mass is measured in grams, and the volume is measured in milliliters or centimeters cubed. They essentially mean the same thing. And keep in mind that density is an important concept when we talk about things that either float or sink in certain substances. So if we look at the density column here on the right, the things that have lower density are floating closer to the top, where the things that have higher density sink towards the bottom. So for example, corn syrup has a lighter or less density than honey. And so you actually get a really neat column here. I'm actually hoping to be able to make one of these in class someday because it's actually pretty cool to look at. But keep in mind, the formula for density is mass divided by volume. So we'll be using this in a variety of calculations here in just a minute. So let's take a look at a couple of problems related to density. In an experiment to identify an unknown substance, it is found that 31.45 milliliters of a substance has a mass of 16.32 grams. What is the density of the substance in grams per milliliters? Well, let's take a look and figure out what we know and what is unknown. I feel like that's one of the best ways to go through and solve these types of problems. Well, we have 31.45 milliliters and 16.32 grams. So we know our mass is 16.32 grams. And milliliters is a unit of volume. So we know our volume is equal to 31.45 milliliters. The question is asking for density. So we need to use our formula, density equals mass divided by volume. So we take our numbers, we plug in, and we solve for density. So D is equal to 16.32 grams divided by 31.45 milliliters. And now we just do our math. Once we do finish our calculation, our answer is 0.5189, and then our units, G over ml, that's our unit for density, is grams per milliliter. And there we go. Pretty simple, and pretty straightforward to solve. So again, just figure out what you know, what is unknown, plug into your equation, and solve algebraically. Doesn't get much simpler than that, guys. Let's do one more problem together. For our next problem, copper has a density of 8.96 grams per centimeter cubed. What is the mass of a piece of copper with a volume of 5.68 centimeters cubed? So again, let's take a look at what we know and what is unknown, or what we're trying to solve for. So we have some information here. The density is equal to 8.96 grams per centimeter cubed. And we also know our volume, which is 5.68 centimeters cubed. Now our unknown is what the question is asking for. And the question is asking for mass. So our unknown is mass. So there's two ways we can do this. We can rearrange the problem first, or we can plug the numbers in and then rearrange them. Either way is fine with me. I'll show both ways. So density equals mass over volume. Remember, we're trying to solve for mass, so we need to isolate that variable by itself. To do so, we need to multiply both sides by volume. Volumes cancel, so density times our volume is going to give us our mass. And then you can plug the numbers in and solve. The other way to do this is go ahead and plug the numbers in first and solve that way. So density, 8.96 grams per centimeter cubed. Our mass is unknown, and our volume is 5.68 centimeters cubed. Either way, to solve for mass, we need to multiply 5.68 times 8.96. So our answer when rounded is 50.9 grams. And that's our answer. So again, the process is very simple. There's three variables here. I give you two and you solve for the unknown. Now these can get a little bit more complicated, but we'll do some of those in class together. So hopefully now you understand a variety of different measurements that are used in a chemistry class. And keep in mind that scientists use SI units to describe matter, not the imperial system like we're used to. The prefixes that we can put before or after, the prefixes that we can put before alter these units into quantities that are very, very large or very, very small. And also keep in mind that multiple SI units can be used to make derived units, just like what we did with our density problems. So hopefully you're able to identify these learning targets. Like I said before, hopefully you've had a good video here. Lots of stuff to kind of keep in the back of your mind. We'll deal with a little bit more with these units as we approach dimensional analysis in our next video. I hope you have a great day, guys, and we'll talk to you later. Bye-bye.